Today we're going to be looking at resistors. Okay? And so what I have here is a selection of resistors. And one of the things that I think you'll notice about them is they come in different sizes. This is a resistor. This is a resistor. This is a resistor. And this is a resistor. So as you can see, lots of different sizes of resistors, and they have different sizes because they can handle different power. So the amount of resistance doesn't necessarily reflect the size of the resistor. So this is a very large resistor, but it only has a small amount of resistance. So this here, we've got it labeled here for you. You can see it's a 5 ohm resistor, so that's actually a very small amount of resistance, but it can handle 225 watts, which is a very large wattage. Okay. This is a much smaller resistor, but it's actually 330 ohms. So it's way larger than this 5 ohms. So this is 330 ohms of resistance. However, it can only handle 2 watts of power. So this is a 2-watt resistor. This resistor is a 1 watt. So you can see it's, less than half the size of the 2 watt. And this one here is a 1/4 watt. Okay. So looking at the size basically dictates the wattage, okay, how much power the resistor can handle. All right, but the actual resistance is a separate factor, and we'll talk about Ohm's law later, which kind of governs what resistance is. But the resistance is really made of anything. Okay, so if you look here, even here's a piece of wire. It's a resistor. All right, so everything has resistance. When you talk about current flowing through, resistance is the opposition to current or electron flow. And so anything, whether it's a simple piece of wire or something that is officially built to be a resistance, okay, everything has resistance, all right? But for these specific resistors that are built for resistance, all right, they will have a rating on them. So if you look here, there's written on here somewhere on the actual resistor, you'll see it'll actually tell you what that resistance is and probably what the power rating is. So I mean, this is a very large resistor, and so you can see that very easily there. If you look here, here's a slightly smaller resistor than this one. Okay, there's actually 3 mounted on this board. But if you look right here, you can see the writing. There is writing on here, so you can read that, and it tells you various information, including what the resistance is. However, when we get to these smaller resistors, this one maybe you could put writing on, but as the resistors get smaller and smaller, it becomes virtually impossible to see any kind of, or to put any kind of writing on there that would be readable. And so therefore we have the resistor color codes. Okay, so if we look here, okay, there are resistor color codes. So a resistor can have multiple bands of colors on it. So this one here is probably the easiest to see. This 330 ohm here is probably the easiest to see. You can see that it's orange, orange, brown, and then I guess that looks like a silver color. Sometimes the colors are a little bit hard to tell which is which, but this one's pretty clear here with this orange, and then a brown. Okay, those three are pretty obvious. The fourth one looks silver to me. Okay, and each one of those colors means something here. So when we look at these color codes here, you can see that you could have possibly a resistor with only 3 bands. Notice that you start counting the bands at the edge that is closest to, or the band that is closest to an edge. So that way you know which one to count. And so if you see if it's a 3 band, okay, the third, since it's missing a 4th band, then that means it's a 20% tolerance resistor. Nowadays, you don't find too many. You're probably not going to go out and buy a resistor that only has 20% tolerance. That's quite a large tolerance. That means like a 100 ohm resistor, for instance, could go from 80 ohms up to 120 ohms and still be within tolerance. Okay, so that's quite a large amount of range there. So very common, you'll see the most common are a 4-band resistor where the 4th band has a color and that color indicates the tolerance. Okay, and as we get to higher tolerance resistors, they may even have 5 bands or possibly even up to 6 bands. Okay, but the most common is usually a 4-band. 5 bands are becoming more and more common as our production and accuracy of the resistors increases. All right. So, but if you look here, you can see on this color code, the different colors. We have black, brown, red, orange, yellow, green, blue, violet, gray, and white. Okay, so those are the main colors that you would find on the resistor. And so each one of those has a digit 0 through 9. And so one of the things you may, if you're trying to remember this, it's kind of difficult. And so there's some different mnemonics which help us to remember the order of the colors. So as you can see here, here's one that somebody came up with called "Bad Bear Rots Our Young Guts, but Vodka Goes Well." And then they added in the silver and the goblets, silver goblets for silver and gold. But you can see the color there is black, blue, red, orange, yellow, green, brown, violet, gray, and white. And so using a mnemonic, if you look on the wiki site, they give you several different mnemonics here that you can, you just need to pick one and learn it and remember it. The idea of the mnemonics is they help you remember the order. So it's black, brown, red, green, okay, black, brown, red, red, orange, yellow, green, and then, I'm looking at this one. This is wrong. It's black and brown. So forget that mnemonic. That one's wrong. Okay. But if you look here, black, brown, red, orange, yellow, green, and then blue. So that one I had on this screen, it had brown and blue are backwards. So it's black and then brown. All right, so if you look at this resistor here, if I flip back over here, so if you look at this 330 ohm resistor, again, you can see that there's an orange there, orange, orange, and brown. Okay, so orange is 3, and brown is a 1. Now, if you look at this one here, okay, this is a slightly different one, but the first 2 colors there, and I'm not sure how well they're coming out, but it's orange, orange, but the third one is black. Okay, so if we look over at our color codes here, we see brown, or in black, right? Black is the first one, and it's a 0, and brown is a 1. And so what you get there then is the orange, orange, brown. Brown is a 1, so that's 3, 3, and then 1. That third one is the multiplier, so that's 33 times 10 is 330 ohms. But this one here is 3, 3, black, so it's 33 times 1 times 10 to the 0. So it's 33 times 10 to the 0, which is 1, which is only 33 ohms. Again, it has nothing to do with the size of the resistor, but those color bands tell us the amount of resistance. So this was 3 times 10 to the first, which is 330 ohms on this resistor. And then this resistor is 3 times 10 to the 0, which is 33 ohms. Okay? And so that's what these resistor color codes are for. And so it's very important that you remember those color codes. All right, and so like I say, there's a lot of different acronyms, or excuse me, mnemonics here that people have come up with, okay, to try and remember. And so you just kind of need to read through one of those, and there's the vodka one. Bad booze rots our young guts, but vodka goes well. All right, but again, remember it's black, brown, red, orange, yellow, green, and then blue. And then violet or purple, if you want, goes gray, and then white. Okay, so bad booze rots our young guts, but vodka goes well. All right, and so these are, pick one of these mnemonics. There's a lot of them there. You don't have to use the vodka one. Here's one. Blackbirds run over your biting visible gray worms. Okay, I don't know about biting visible worms, but so they've just come up with a lot of different ones, but you just need to pick one and then learn it and remember it, and then you can always just write down. You'd be like, okay, BBRY ROY GBVG, and then write down the numbers that go along with those. All right, so we do need to know these because you'll be looking at resistors. Now this resistor this resistor is mounted on a piece of plastic here, okay, and we mount these on here so that we can connect these up easily in the lab. But a lot of times when you're working with resistors, you're going to just have this tiny little resistor here, and the only way to know how much resistance it is to read those color codes. So you need to be able to look at those color codes and see what those are. All right. So, but in the lab here, we're going to be connecting resistors up. And so we have a pegboard over here. And the idea is that we can take this pegboard and set these resistors in, and they'll set down like this. And then we'll have these jumpers, and then we can connect these jumpers up and onto the board. And it usually works better if you kind of stand them up like that. I mean, you can clip them this way, but what will happen is sometimes when you start trying to connect more complex circuits, these things may swing around and short out maybe where they shouldn't. Okay, so if that's a problem, you just want to put a little alligator clips in this way. But so these mounted resistors are mounted on here so that we can put them in the pegboard and connect them up. Okay. All right, so let's take a look at using a meter. Okay, so this here is a digital multimeter, and if you see right here are some terminal connections. All right, and this top one is labeled with a V for voltage. So there's a V for voltage, and then there's an omega symbol, the Greek omega symbol for ohms or resistance. And then, of course, there's a common. So if we want to measure resistance, first thing, to use this meter, there's this handle on here. And if you just kind of pull out at the sides, you'll slide that down. So when it's on the shelf or on the cart, the handle will be down so they can be stacked up. But then what you can do is you can pop that out so that it'll kind of sit up at an angle. Okay, and then of course you'll need a power cord. Okay, so just a standard power cord like you might plug into a PC. So we'll want to plug that in, and then it'll plug in at the back. And then we're going to turn power on. Okay, or possibly power is already on. You can see the display coming on here. All right, and then we're going to take a pair of meter leads, and we'll take those off of there. Okay, and we're going to connect the positive to the V ohm to measure resistance, and then we'll take the black lead and put on the ground. Okay, so if you see here, remember this large one is the 330 ohm resistor, and so what I'm going to do is I'm going to connect this up. All right, resistors, it doesn't matter which way you connect it. You can get the same resistance either way. All right, but if you can see the display here, okay, the display, right now it's trying to show a voltage and it's just bouncing around because there's no voltage there. All right, so what we need to do is come over here to the omega symbol and press that, and now we can measure the resistance. Now, if it's not connected, it'll read overload. Okay, I don't know why they say overload. It basically means it's an open circuit, there's no current flow. But when you connect it, then you'll see that it's reading. Okay, so it's going to read. So you see here, this is reading 0.34825, and then those rest of those numbers. These are very these are 5-digit meters, so they're supposed to basically give you 5 decimal points. Okay, but what it's going to do, you really just want to read those first 3. Okay, that's going to be your accuracy, and you may want to look at the 4th one and round up possibly. So you see that this thing is reading 348 kilo ohms, but there's a 0 period there, right? So it's 0.348 kilo ohms. All right, so it's supposed to be 330 ohms, and but it's got a tolerance there, so it may not be exactly 330 ohms, so it's slightly higher than that. Okay, now you see it may be bouncing around now. That's usually because we're just not getting a good connection. Okay, so if you're not getting a good reading, you just want to make sure that you're getting a good connection there, and it shouldn't bounce around so much. Okay, again, sometimes it's better to go directly down on them. Okay. All right, so I don't know if I bumped a button here. not making a real good connection at the moment. Alright, now when you measure resistance, make sure that there's no power applied and the resistor should be separate from the circuit. Okay, if we wire up like both of these resistors here, okay, this is the 330 and then this one is another 33. So you see it's now reading about 0.4. So we're about 400 ohms here because the 330 was reading more like 350 and then we add another 33. Okay. Okay, and it's some reason this meter is bouncing around here a little bit. Okay. So when I first connected it, it was reading okay. There we go. 381. That's a good reading. All right, so it's 33 ohms, but it's really about 350 ohms, and then this other one is another 33 ohms. So if we disconnect it and just read this one, it should read 33 ohms. So you see it's 32.95 ohms. So this one here is, this smaller resistor here is very accurate, very close. It's supposed to be 33 ohms. And it's 32.99, or actually, see now it actually bumped up there just a hair to 33.0 ohms. So this one's right on. But this other one over here, this is an older resistor, and the tolerance on it's not quite so good. So if we, and sometimes when you're trying to read these, you may want to clip actually right on the wires there. See if I can move the camera here a little bit closer. So you see I'm not actually on the terminals that we have here, but I'm actually got the meter wired right on there, and you can see it's reading 0.3479, which is about 0.348 ohms. Now remember, it's got some tolerance there. Silver is 10% tolerance, so that means that it's 330 ohms plus or minus 10%, which is a plus or minus 30 ohms in either direction. So it's only, you know, about 15 ohms above the rating. So this resistor, even though it's not reading 330, it's reading 347, it is within tolerance of the resistor. Okay, because of this silver band on the resistor, that silver band there says it's allowed to be plus or minus 10%. And so it could go all the way up to 363 ohms, would still be within that 10%. Okay, so this, you know, this resistor, it's not reading 330, it's reading 348 ohms, but it is within tolerance. So it is a good resistor. It, based on its definition, it's allowed to be 348 ohms, okay, and it's meeting tolerance. So this resistor is a good resistor. It's in tolerance. But remember, you want, before you do any calculations or any labs, you always want to measure each resistor you're using in the lab and then do your calculations based on the actual resistance that you measured and not the color-coded value of the resistor. All right, so that's all for today.